Hi everyone, welcome back. We are going to jump right in. So we're going to take a look at a little bit of review to start the unit before we get into the new material. So just quickly going over some definitions that you're going to need to know. Remember that W is our symbol for whole numbers, and in our set builder notation with our funky brackets, our whole numbers are 0, 1, 2, 3, and just continue to infinity, and we have our 3 dots showing that they continue. Integers, we have a symbol of I, and we know that integers are both negative values and positive values. They are still whole values, but we have negatives as well as our positive values. And again, our dots just demonstrate that that continues. We also need to know our definition of our powers. So if we have 2x to the power of 3, or to the exponent 3, we have our base, and our base is what the exponent is actually on. So we have a base of x here. We have our exponent is the actual number on our base. So that just means that there are 3 x's all multiplied together. So if we knew the value of x, we could multiply that 3 times to get our value. Our 2 out front is what we call our coefficient. And that is simply the number out front. So we have 2x cubed. So looking at our power laws, we know that if we have x to the power of 5, it just means that we have x times x times x 5 times. And we're also going to multiply by 3 x's all multiplied together. Well, if we simplify that, we know now that we just have 8 x's all multiplied together. So again, if we knew the value of x, we would just multiply that 8 times. Well, going straight from here to here, all we're doing, as long as we have the same base, okay, if those were different bases, this doesn't work. All we're going to do is add our exponents. Second one, now we're dividing. So we're going to write this in division, that we have y 7 times on the top, and we have y times y on the bottom. 2 y's multiplied together. Well, we know that anything divided by itself is just equal to 1. So we can cancel 1 y on the top, 1 y on the bottom. And once we do that, we get y multiplied together 5 times. So all that's left is y to the 5. Again, the law that tells us we can go directly to here is that if we have the same base, again, it has to be the same base, now we can subtract our exponents. C, now we have a power to a power. So this 4 outside of the brackets tells us that we're going to have a to the power of 3 4 times. Well, our first power law tells us that we're going to add up all of those 3's. When we do that, we get a to the power of 12. Again, the law that tells us we can go directly to here means that if we have a power to a power, we are simply going to multiply our values. And again, if there's nothing in between them, that just denotes multiplying. Well, part D, we have the same idea. So the squared outside means that we're going to have 3m to the 6 times 3m to the 6. And when we multiply our terms, we multiply our numbers. So we get 9. And we add our exponents. So all this demonstrates to us is that if we have more than one thing inside the brackets to an exponent, we have to apply that exponent to all the parts inside the brackets. Even if it's a number, if it's a variable, that exponent outside the brackets applies to everything inside the brackets. So if we look at it this way, even if it's a fraction, so we're going to have 2 to the power of 3, x to the power of 6, over 3 to the power of 3, y to the power of 3. So again, that exponent applies to everything inside. When we simplify that, we get 8x to the 6 over 27y to the 3. So again, even if we have a fraction inside the bracket, that m applies to all parts. Next, we have 4 to the power of 0. And what we can look at is that what we had to start with was 4 to the power of 3 over 4 to the power of 3. Well, anything divided by itself has to be equal to 1. Well, we can also think about that as our exponent laws, that we're going to subtract those exponents, so that's equal to 4 to the power of 0. Well, anything to the power of 0 then means that it's itself divided by itself, which means that it has to be equal to 1. Okay, so we can go directly from here to here, knowing our power law or our exponent law, anything to the power of 0 is equal to 1. Now, if we had 4 to the negative 2, we could have had a question of 4 to the power of 2 over 4 to the power of 4, which we can look at as 4 times 4 over 4 times 4 times 4 times 4. And again, anything divided by itself cancels out, which means we have 1 times 1 on the top, which is 1, and 4 squared on the bottom. Well, notice that in power laws, that would mean 2 minus 4, which means 4 to the negative 2. So these two values or expressions are equal. Because we can't solve a negative exponent or calculate a negative exponent, we always want to simplify it to its positive exponent first. So if we have anything to a negative exponent, we can flip it to make it a positive exponent. And it's the same thing if the negative exponent is on the bottom. We now flip it to the top to make it x to the power of n over 1. And we don't have to write that over 1 because it's just equal to x to the power of n. Now, it's the same idea whether we have a fraction, a single expression, multiple parts of an expression inside the brackets. We know that the exponent outside applies to all the parts inside. Well, if we look at simplifying this to our positive exponents, we're going to flip that 2 to the bottom to make it a positive exponent, and we're going to flip that 3 to the top to make it a positive exponent as well. When we calculate this, we get 9 over 4. We'll notice that we could have gone straight to this because we know that both things inside are going to have a negative exponent. That we're just going to flip the entire fraction inside the brackets and make it a positive exponent. And then we can apply that n inside. It doesn't matter which way you do that as long as you simplify your final answer. So looking at some examples. Our first one, we're multiplying. We do have the same base, so we're going to add our exponents. In this case, we're just going to have to write it as 7 plus y, all as part of the exponent. Part B, we're going to simplify by multiplying our exponents first. Notice that we want our answers with positive exponents. So we're going to flip that to the bottom and make it a positive 14. So 1 over 3 to the power of 14 is our final answer. And notice that our question said simplify. It didn't say evaluate, so we don't have to go any further than this. Part C, we do have all the same base, so we're going to add all of our exponents. So negative 6 plus 1 plus 4 means we're going to get m to the negative 1, which we're then going to flip to make that 1 over m. Notice we don't have to write the 1 because we know that it's just m. Part D, we're going to multiply our exponents. Remember, we're going to take that negative 5 to all the exponents inside the brackets. So we're going to get a to the negative 15, b to the power of 10. We don't want to have a negative exponent in our final answer, so that a to the negative 15 is going to flip to the bottom. It's still one term. So we're going to write this b to the power of 10 stays on top, and a to the power of negative 15 flips to the bottom where it becomes a positive 15. Same thing with part E, remembering that all the parts inside the bracket we have to apply the negative 2 exponent to. When we do that, we get 6 to the negative 2, x to the power of 6. Remember, there is no separation. That is still one term. This is all one term. And we have divided by y to the negative 8. So we have to flip our negative exponents only. So we are going to take our 6 to the power of 2 to the bottom. We also are going to leave our x to the power of 6 where it is. It doesn't have a negative exponent, it stays where it is. But we're going to bring that y term to the top where it becomes y to the positive 8. And now we're just going to simplify our 6 squared. So x to the power of 6, y to the power of 8, all divided by 36. And that's our final answer. For part F, we can rewrite this in a simplified version if we wish. We can write it as negative 30 ab to the negative 4 divided by 6a to the negative 3b to the 2. Notice that this is still all one term. There are no pluses or minuses separating our parts of our expression. So this is all one term. It has to be one term in our final answer as well. Just simplified, meaning that we should have just a single a term and a single b term. So first of all, looking at our numbers, negative 30 divided by 6 leaves us with negative 5. We're going to subtract our exponents. So a subtract negative 3. So this is where we need to pay attention to our signs. Subtracting a negative means we're going to add 3 to the a. When we subtract 2 from b, we're going to get b to the negative 6. Again, only the b part of our term is going to flip to the bottom. Negative numbers, like the negative 5 out front, do not move. We don't do anything with those. A negative number is a negative number. So we simplified a negative 5a to the power of 4 over b to the power of 6. And again, this is all one term, nothing separating the parts. This is one expression or one rational expression, meaning it's a fraction. Okay, so you have some questions that you can practice on your worksheet to refamiliarize yourself with these laws. You also have answers at the bottom of your worksheet so that you can check. Don't use those answers before you have tried the question. Those are for you to check and make sure that you're on the right track. Okay, take care and we'll see you shortly.